I'm Eric Anderson. I'm a gRPC maintainer. And let's go ahead and talk about some service meshes. A service mesh is an infrastructure layer for applications that enhances service-to-service communication. It handles things like encryption, load balancing, observability, and resiliency features. It decouples them from the application code, and so then you can manage those separately. This also allows developers to focus on the business logic, while the service mesh ensures the reliable and secure service interactions. So, does my service mesh work with gRPC? This question I've gotten from some developers, and the general answer is yes. gRPC does require HTTP2, but that's commonly supported. There's a common related question: which service mesh works best with gRPC? For both of those questions, work is dependent on the problems you in particular are using the service mesh to solve. So keep that in mind. It's sort of centric on what you're trying to do. And the problem is even you is a little bit fuzzy here. Your team may have a particular need, but other teams in your company are optimizing for their own needs. So you might have an infrastructure team that wants it to be easy to deploy, but a sister team that wants features, and then you have yet another team that wants performance. So I suggest you to keep that in mind, that it's a simple question, but even then it's getting a little interesting there. So with these sorts of different objectives in mind, let's look at how gRPC interacts with the service mesh. And to do that, let's look at some service mesh architectures. Here's a rough list of architectures. Different people might use different names, but these will work for this presentation. Gateway, daemon set, sidecar, proxyless. Let's look at each and how they differ. And so we're going to start with not a mesh. We just have our application, and services talk just directly to each other. This can work, but can have load balancing problems. Generally, it lacks security, and it can be slow to respond to policy changes. By being slow to respond to policy changes, I mean if you want to change a setting, you have to roll out a different version of the application. And that can be particularly nasty if you need to roll out for clients. If you are app 4 in this picture, it might be hard to get app 1 to redeploy. You can throw a proxy in between the client and the server, and now you get good load balancing, and you can quickly update your policies for the service. And you don't have to restart or redeploy the client or the server. And I'm using the term gateway for this model, which might seem strange since we most often use gateway when communicating between meshes, but the architecture is really the same. If you compare this to a typical service mesh, the main feature missing is security. Note that the proxy could be shared across services, or each service gets its own proxy. And now we get to the architecture of the first service mesh. We put a proxy in each node with some kernel rules so the proxy controls the application network communication. Now the proxy can enforce and use mutual TLS to encrypt the network traffic and restrict access to the service. The proxy uses Kubernetes daemon set to run on each node and then is shared between pods on the node. As we continue, then there's the second architecture that people associate with service mesh. Instead of having one proxy per node, you can instead have one proxy per pod. The difference between this and daemon set isn't as much about features, but about deployment and resources. If one application does a ton of traffic, you can give more resources to that one pod's proxy. On the flip side, though, it's going to share the pod's resources, which could potentially add complexity to deployment. And since this is a gRPC talk, let's go back to the first architecture slide. The point of the service mesh was people had applications that couldn't do various features themselves. Adding those features to many different client and server libraries for various languages was too much work, so we're like, we'll use a proxy. But if the clients and servers have those features directly, then you could do it without the need for proxies. So let's look at our list of architectures again. There's some flexibility to the architectures. For example, Linkerd is swapped to sidecar so it could be enabled per pod. And that was made possible by a more efficient proxy. Istio with ambient mesh swapped to a smaller daemon set proxy to simplify resource management because the proxy no longer competed for the application's resources. But why would Istio use both daemon set and gateway? We may not have the full view. When we talk about proxies, there's two main types that matter to an architecture. There's layer 3 or layer 4 from the OSI reference model, which is network or transport layer. These types of proxies work at the level of IP or TCP, and we'll just group them together and call them L4, because even though technically they might work at different layers, they produce similar results to each other. Then there's also layer 7, which is the application layer from OSI. For us, this type of proxy typically deals with HTTP, although it could handle other protocols as well. I know some people may only think of L7 proxies as being proxies. Some L3 proxies we just call routers, for example, and people may not think of them as proxies, but they are. They're doing a lot of the same things. And that should remind us that the implementations matter. Routers are so fast that we really don't even consider their latency cost. They're just there, and it's good. And deployment and maintenance is also abstracted away. We don't think about what size machine to use generally or the CPU usage. We just have it run. As a generalization, L4 proxies tend to be more efficient, where L7 proxies tend to be more featureful. With that in mind, again, why would Istio use both a daemon set and gateway? Well, the answer, one is an L4 proxy, one is an L7. All right, it's been a few slides since we talked about gRPC. So what makes gRPC special to meshes? And it's pretty simple, HTTP2. HTTP2 can use a single connection for many requests, and that's, well, different than HTTP1. Whenever we look back at those proxy types we had, L4 proxies can only load balance connections. HTTP2 needs fewer connections, thus gets less frequent load balancing. Many of you may be familiar with this with Kubernetes. If each client causes a small percentage of the overall server load, Kubernetes native load balancing might work okay. It works at the L4 layer. But for heavier clients, you need to do L7 load balancing, which gRPC does natively. That's why people then use the headless services. And HTTP2 causes similar behavior for meshes whenever you're deploying those. So, for example, how well would this work for gRPC? We're using the newer Istio architecture, but we elected to not use a waypoint. The proxies can only do L4 level load balancing. So this will behave similarly to Kubernetes load balancing. If you have small clients, this might be fine. But otherwise, you will want to add a waypoint for per RPC load balancing for better distribution to the backends. As another example, now with Linkerd, this looks very, very similar, but now the proxies are L7. So this is actually fine as this. You don't need any more. I'm doing well for time, so I'll give a little extra here. You might wonder what's going on with HTTP2. Linkerd can actually upgrade from HTTP1 to HTTP2 and whenever it uses things. zTunnel with Istio can also use HTTP2 for its own communication. And then we've got gRPC using HTTP2. Why would we be doing HTTP2 for all of this? And the answer is actually security. The handshakes to do security can be quite expensive. And if you're doing plain text, you don't notice, it's fine because you don't have the TLS handshakes. But the moment you start trying to do security, the making connections becomes much more expensive. And so that's why these different systems try to reuse the connections and avoid unnecessary handshakes. If your service is performance sensitive, then proxyless ends up making a lot of sense for which architecture you might want to use. Proxies can add latency, and so whenever you're trying to vie for all the performance, you want to remove any sources of latency you can. If you use gRPC almost exclusively, then proxyless might be a good fit, because I've seen some developers choose it because they didn't need to worry about deploying the proxies. They could sort of iteratively just roll out to particular workloads and turn on the mesh a deployment at a time. But that assumes you don't need the proxies for non-gRPC traffic. If your applications use a mix of gRPC and other things like REST, you're going to need to deploy and manage the proxies anyway. So that's fine. You would use a regular L7 proxy-based mesh, and that will work fine with gRPC. Depending on your needs, you could still try to mix this with Proxyless, but your mesh would need to support it. So to demonstrate what I mean by optionally using Proxyless, let's take a look at Google's Cloud Service Mesh. It was previously called Traffic Director, by the way, if you're familiar with that name. Cloud Service Mesh supports Proxyless, but you can choose for each pod whether it uses a proxy or not. And yet it still forms a single mesh. So app 1 in this diagram would be Proxyless, but app 4 is using Sidecar, yet they can communicate directly with each other. I'm aware that Istio also has experimental support for Proxyless. gRPC did introduce an incompatibility there, but I'm sort of hopeful that might get resolved in C++ and Java soon. All right, thank you. Do we have questions? All right. Service meshes are easy. And there's not been any load balancing concerns.
Thank you, Eric. That's a wonderful presentation. I want to ask you, I know we've all along been talking about HTTP2 and using proxies and proxyless in this combination, HTTP 1.1 and HTTP2. And we have HTTP 3 around the horizon. And we believe the connection time is relatively faster because it's 0 to 1 RTT, because it combines TLS and transport handshake in one go. So what are your takes when we will be able to have a service mesh or a proxyless model that supports these?
HTTP3 does have fast handshake. However, very few people can actually use 0 RTT for something like gRPC. 0 RTT is actually really, really great for browsers that do like a GET request. But anytime you're doing anything authenticated, the 0 RTT can be replayed. And so you don't get to do it for posts. And I think even puts you don't get to do it for. So for most of the things we talk about, the 0 RTT isn't actually able to be achieved. The 1 RTT could still be there. TLS 1.3 gets you close to that with the normal TCP. You can reduce handshakes, but overall here we're reusing handshakes over a long period, right? So maybe if you've got cross-continental, you could shave that down a little bit, but HTTP3 works really, really well across the internet. And we do, for mobile, have some HTTP3 ability, depending on which language you're in and platform and stuff like that. But for the data center, it's got some benefits and some drawbacks, and it's just a little bit more muddled and less obvious. So it's there, depending, like some proxies can support it, but gRPC still doesn't do it natively.
Okay. Sort of a related question. Do any of the GCP services support HTTP3 already for gRPC?
Do any of the, say that again?
Any of the GCP services, the Google Cloud Platform services support, proxies, support HTTP3 already, and that we can leverage for our gRPC workloads. And our situation is kind of unique. We run mission-critical, latency-sensitive applications on long-haul networks. That's our use case. Sometimes the network is not, internet traffic, right? It's not in our favor. We don't control them. So we're hoping HTTP3 can give us
across the internet.
Yes.
Yeah, I believe I'm trying to think of the name. The cloud proxy for GCP, I think it supports HTTP3, and that can then, if you talk to it with HTTP3, you get it to the back end. And then I think some of the Google APIs are in front of a similar proxy, and they can speak it. So I can't say I've tested the specific situations, but I know other people have done HTTP3 in some similar situations. A lot of those are mobile, though. Yeah. So.
Yeah, I have a question with respect to versioning, particularly when you are doing version changes. Which of these service mesh architecture would really scale across thousands of gRPC deployments?
You mentioned version changes, which is rolling out
Yeah.
and dealing with the updates.
Updates or gRPC, I mean, schema updates and those sort of things.
For schema updates where you're updating the versions and you're wanting the servers to be compatible with the old clients and stuff, they would all work pretty similar. That's going to be more at the application logic level. The one sort of difference is if you want to do A/B testing or red-green or all those sorts of variations,
Yeah.
The meshes have tools to help with that.
But among all these service mesh architectures, which one really actually scales well for this version management?
I'd say in general, the scaling would be mostly in terms of number of nodes or pods, that sort of thing, the number of clients and servers. The versions probably doesn't factor in very much at all.
I see.
I think there's some behind you.
Hi. Can you please elaborate on why Proxyless is recommended for gRPC heavy and how the service mesh would look like? Where would the features of service mesh be implemented in that case?
Yes. So if many gRPC heavy workloads, it's really nice if you could just spin up a single job and start using Proxyless for this one service. You can try it out, see how you like it. It doesn't need to be a full Kubernetes cluster choice or things like that. I know some of the other meshes also let you spin it up per pod, but you get that sort of benefit where you can easily try it out. You make a small change in your code and you get to choose and compare whether you're liking it. It just lets you ease in. gRPC will be implementing the various features. And yes, it is possible that some features that you want are not implemented by gRPC. In those cases, yes, you would end up wanting to use a proxy. A lot of the features that people are wanting are in gRPC. So if it's some of the run-of-the-mill stuff, check it, and it probably is doing what you want. If not, we might want to be interested in figuring out what that feature is. But yes, if a new version of a mesh comes out tomorrow, gRPC might not support whatever that feature that is, where the proxy, L7 proxy, would support it potentially. That is something to consider. So yes, Proxyless might have reduced features, but for a lot of gRPC users, that's not a concern. It'll either be a concern for you or not. And some people might be talking about using WASM and things like that. Like the more complex you get for the feature usage, the more likely that gRPC is not going to support that.
Thank you.
So I got some questions about security. And I think one of the slides you showed that you got to support different models where you can have the sidecars running with the pod and talking to gRPC to the other end or vice versa. So I guess, generally speaking, if the gRPC is a serverless proxy, it saves, manage the sidecar. I understand it's still managed on its own, but in general speaking, managing a sidecar, it is overhead, is other concerns you have to kind of think about in terms of networking, all the other ones, right? So what is the benefits of, if we're all coming back with this proxyless proxies or the proxyless model, why would I want to choose the sidecar model at all?
For the original, you would, in my talk, there was the 3 points. The third point was you've got a mix of things.
Okay.
The meshes they came out, and you've got these legacy applications, or you're just doing things 5 different ways, and it's hard to get all the features everywhere. And proxies work really great in that situation. You are trading something. You're either trading the resource costs or the latency, and many of those you may pay and not even care because it's such the value you get is so great compared to those small costs. But yes, if you're mostly a gRPC shop, there's a lot of communication, you're doing tons and tons of RPCs, then it's a different calculation.
So I promise, last one question. It's on the gRPC when you talk about security, and I totally agree with you. Making the connections and is going to be expensive, right? So this is where once you have it, you probably only do it once. Is that how the price the proxyless model has really worked? You only do an authentication authorization at the time of when the connection was made. Is that how you do it, or?
So gRPC will behave similarly to how the proxies would do it if the proxies were there. And you try to reuse the connections, and there's some details on authentication, exactly how you're doing authentication, but the normal mesh proxy authentication would be happening the same way.
Wow. The normal one is you do it for every single transaction, right? When you come in, you do that because it's more not like HTTP 1 level. So that's kind of every single transaction. I'm hoping the gRPC model is really, we kind of moved away from that.
For the meshes, whenever there a lot of the authentication they're talking about, you can talk about two authentication. One is service-to-service authentication, and one is like end-user authentication.
I see.
The service-to-service authentication you can do once per connection, and then they try to reuse those connections.
Makes sense. Thank you.
We are out of time. I will be over here, and y'all can find me and talk to me. Thank you, everyone.